this is week 6. These are the live problem solving sessions in which we discuss previous year's assignment problems. So since this is week 6, so we will be discussing the previous year's assignment problems from week 6. That is assignment 6, quiz 6 and programming assignment for week 6. So in this week, the focus has been on using strings, how to use strings and the library called string, and also recursive functions, like what is recursion, how to write recursive functions. So these are the two main aspects that were discussed in this particular week. So let us get started with solving the questions. The first question is, the following code will, basically we need to predict the output of the following code, and these are the 4 options. So please take a few minutes to solve this question and then I will discuss the answer. Okay, so the answer to this question is option A. Let me get my pen. It shifts every letter in a given word by the value. So this function takes 2 arguments, word and value, and it shifts every letter in the word by the amount value. So let me write this in Python and show it to you as a demonstration.
So let me just write the question over here and see the output. I'm just copying the question. Okay, somewhere something is wrong. It is showing some error. Yeah, letters it should be. And then return new. Oh, sorry. Return new. Fine. So let me now call this function. I need to call the function as well. So let me say I take input from the user, and then I will call this function shift, and then I will print it. So let us run this. Let me enter the word like this, word itself. Oh, missing require, oh, something is missing. Oh, shift comma value I need to give. So let's say value is 3. So let me run this. Once again, word. So see, shifting is done by 3. So W goes to Z, then O goes to P, Q, and then R goes to S, T, and then U, D goes to E, F, and then G. Let's say I want to do shifting by -3. Again, I will enter word. See, it subtracts 3. So if you go, let's say T plus 3, that gives W. So W minus 3 is T. Then L plus 3 is O. L, M, N, and then O. O plus 3 is R. P, Q, R. So R minus 3 is O. Similarly, D minus 3 is A. So this is working as.
Okay, coming back. Next question. Another question in which we have to predict the output. So there are a lot of questions in this week that are based on predicting the output of Python codes. So we would be switching back and forth between these lecture notes and Spider, so that we can write the program and see the output and confirm that indeed these are the correct answers. So okay, next question. What will be the output of the following code if the input is the joy of computing? Again, it's like a significant piece of code, for loops, if else conditions. So please try to think about this, go line by line, and um, select the correct option. Then we will discuss. Okay, so the correct answer to this question is option C. And again, let me write this in Python.
So let us look at the next question then. I still need the import string, but rest of the stuff I don't need. So lowercase letters are in string dot ASCII lowercase, and then upper case are in string dot ASCII underscore uppercase. It's a really big piece of code. Index plus, okay, let me just have a look at the question once. So lower index, and then there is plus 2 over here. Oh, some part of the question is missing in the notes. I'll update the notes. So here then modulo 26. Why modulo 26? Because we want to cycle it. So after Z, we want to come back to A. So I'll change in the lecture notes as well. So this modulo 26 is important for cycling. Then elif ch in upper So this is the thing, and then we will return new word. And then to call the function, we will have this print command. The joy of computing. Okay, so let us run this. See, we get this answer that we expected. Sorry, that F was capital F that they had written in the question. I had made that small, so that is not a thing. So the joy of computing with O and F both capital in off. So see, W, J, G, M, Q, A, then R, I, and then F, Q, O, R, W, V, K, P, I. So this is the answer.
Coming back, next question is about recursion. So we learned how recursion can simplify our programs, or basically it's like a different way of writing certain programs. So which of the following is true about recursion? Recursion increases the speed of the program, it decreases the speed of the program remains the same, and recursion is easier to understand than non-recursive programs. So we need to select the correct option. So for this one, A is the correct option. Recursion increases the speed of the program. Next question, again on recursion. What will be the output of the following program? So here means just the function name is given as recursive. It is not really a recursion based program, in the sense that the function recursive is not being called, it's just called recursive. So the output of this code is going to be what? So take a few seconds to answer. Okay, so the correct answer is calculating product of first n numbers. So this is essentially what is known as factorial in mathematics. So factorial of a number is the product of the first n terms. So let's say factorial of n would be 1 into 2 into 3, so on and so forth up until n. Next question. So okay, before that, let me um, write this piece of code in Python and show it to you.
So next question. So this is the function and I need to call the function. Let me call it print. Okay, so let me run this. So it gives 3 factorial, which is equal to 6. As I said, this function is essentially mimicking a factorial function. See, 4 factorial is 4 into 3, which is 6 into 2, 12. So that is how this piece of code is working. We can also use the built-in command math.factorial. So what we can do is, see, both of them will give the same answer. Wait, why is this? Something is going wrong. Wait, something somewhere is going wrong. Let me comment this part. This is doing for only one iteration. I don't know why. Oh, so this is incorrect actually because this is not a recursive function. So it is just doing a product of the number and number minus 1, just the last two numbers. So 5 into 5 minus 1, that is 4. And if we put in here 4, then 4 into 4 minus 1, 3. That's how it is doing. It is not doing product of first n numbers. So this part is incorrect. The question is incorrect. There is no correct option according to this given piece of code. So for this piece of code, the options given in the question, they are all incorrect. So here it is only doing product of the number and number minus 1. Just product of two numbers, not the product of first n numbers. If we had to do recursively, then I need to put in this. Now let's see. So now it is giving the correct thing. No, now it is doing sorry, here it should be returned num and then else, like this. Yeah, sorry, even that was correct. I need to put 5 here. See, now it is correct. And if I check, let's say 4 factorial, so there seems to be an error in the question. I will correct the question. So it needs to call the recursive function recursively. Otherwise, if we just do num into num minus 1, so then it will return only product of two numbers. If you want product of first n numbers, then we need to have this recursive calling of the function.
Okay, so now moving on to the next question. What will be the output of the following program? So this is a recursive program. Why? Because the function name is recursive and it is indeed being called by that particular function itself. So this is what is recursion. When you call, when a function calls its own self again and again. So this is indeed a recursive program and we need to find out the output. Okay, so the correct answer is option A, 55. So this is basically sum of uh, numbers in the list, and numbers in the list are this 1 2 3 4 5 6 7 8 9 10. So you are adding those numbers, and basically sum of sum of first n numbers is given as n into n plus 1 by 2. Here n is 10. So it is 10 into 11 by 2, and that is 55. So let us write this in Python.
So for the next question, I don't need this math. The name is still recursive. Okay, so and then I need to call it with the list 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. See, the answer is 55. Some of the numbers in that list.
Okay, so now we are back. Next question. So as I said, there are a lot of Python based programming output type questions in this particular assignment. What is the output of the following program? Again, this is a recursive program because the name of the function is recursive and it is being called by itself again and again. So what is the output of this particular program? So this program actually does not give any output, it runs into an infinite loop. So that is the case for this particular um, question. Actually, I'm sorry, I've written this question wrong. This is exactly the same as this one. So, the correct question is, let me write it down over here. I'm really sorry about this. So, I'm writing down the correct question. So, this is the correct question, and the answer to this one is runs into an infinite loop. Okay, so sorry for this confusion. And as you people rightly pointed out, indeed this was the same as the previous question that I had earlier written, so that answer would have been 55. So thank you for pointing it out. And this is the correct question now, and the answer to this question is runs into an infinite loop.
So let me write the correct piece of code. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let us run this. Some error it is throwing up. So seems like the correct answer is syntax error. So they have given the wrong option as the correct answer. Oh, sorry. Recursion error, maximum recursion depth exceeded. So it is indeed an infinite loop. You see, it is going into the infinite loop, and then it is showing recursion depth exceeded. So that is the thing. So there is supposed to be two colons over here, that way. Just with that one colon, it is out in list index out of range, but these two colons are required. Now you see it is infinite loop. It says maximum recursion depth exceeded. So this is going into an infinite loop. And if I just scroll up, I just see it is calling the function again and again and again and again and infinite times.
Okay, moving on. So in this week, we also looked at binary search. So binary search is also there, and we need to uh, select in this question what is the correct code for binary search. There are four pieces of code written over here, and we need to select which one is the correct representation for binary search. So take a few minutes. So binary search works on sorted arrays. Okay, the correct answer is option B. And let me write this code for binary search in Python and show it to you.
So let us write the code for binary search, the correct option. I'm just copying that correct option. So this is the recursive way of doing binary search. We had seen the non-recursive way of doing binary search in one of the videos. Okay, so let me call this function now. The list, let us say 1, 2, 3, 4, 5. Sorted list it needs to be. And I want to find the element 2. And my start is 0. That means the first index element 0 and end is 4. Something seems to be going wrong. Let me see where the error is coming. Did I copy the code wrong? Oh, sorry, I wrote this thing wrong. Here it is mid plus 1 and here this is end. And here this is start and here this is mid minus 1. So by mistake I think I selected the wrong option, ticked the wrong option. They were interchanged, this elif and else condition. So option D is the correct option. So let us run this. So see, it tells you that index is 1. So 2 is present in index 1. If I do 3, 3 is present at index 2, it should show very good. If I do 30, then this element is not present. So that's why it is showing minus 100 because this element is not present.
Okay, coming back, what the following code will do. So again, it is a recursive function. We have a function which is calls itself over and over again, and we need to find out the output of this particular piece of code. So the answer is option A. It returns product of elements from fifth index onwards. Let us see it in Python.
Okay, for the next question, let me remove all of this. Okay, so let us. Oh, I need to call the function. Let me call the function. See, it gives me product of all the elements from the fifth index onwards. So let me do this. So 10 into 9, 9 into 8 into 7 into 6. So this is the thing. So fifth index onwards, 6, 7, 8, 9, 10. It is taking the product of those elements. So fifth index is what? The element 6. So indexing starts from 0. So 0, 1, 2, 3, 4. And then fifth index is 6. So it does product of 6, 7, 8, 9, and 10.
Next question. A program which is written in a recursive manner cannot be written in a non-recursive manner. This is false. Why? You have seen this in the factorial example. So we wrote the code for factorial in a recursive manner as well as in a non-recursive manner. So we saw that indeed we can write code in both recursive as well as non-recursive manner. Okay, so let us look at this next question. What will be the output of the following program? So this is a program which is essentially about printing some asterisk pattern, some star pattern. So these print commands are there which prints these asterisks or stars, so to say, and we need to select which is the correct pattern output for this particular piece of code. So take about a minute to answer this question. The correct option is option C. So first it prints 10 asterisk. So see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it prints 8, then 6, then 4, and then 2, and then finally 1. So again, let us see it in Python.
So this is the star pattern. And we do not want to return any element, so return with nothing written means it just goes out of the function and does not return anything. So a string into a number means it prints that string that many number of times. And then recursive of 10 we need to call. Okay. See this star pattern, first 10 asterisks, then 8, then 6, then 4, then 2, and then 1.
Okay, next question. This is very simple. All of you should get this right by now. So this is on lists and indexing in list. What is the index? So we have a list in the list L, which is given as 4, 6, 7, 4, 6, 2, 1. What is the index of element 7? So element 7 is present over here. We need to find out the index of this element. So I believe by now everyone knows how to work with indices in a given list. So indexing always starts from 0. So first element is 0 index, then 1, then 2, and so on and so forth up until the last element. So index of the last element is also given as -1. So this is also another way of indexing. So the index of element 7 will be either 2 or -5. So the correct option is option C, which is 2. Next question, again about recursion. Which of the following is true about recursion? Uh, Recursion always performs better than non-recursive code. Recursive code is easier to debug. Base case is necessary for recursion, and recursive code can be shorter than non-recursive code. We need to select the correct options. This is multiple choice correct type question, so there are more than one options correct in this, and those options are B, C, D. So recursive code is easier to debug and base case is always necessary, and recursive code can indeed be shorter than non-recursive. Moving on. what will be the output of the following program? So we have a string called which is abracadabra, and we need to this is again about indexing in strings. So indexing in lists, arrays or strings, they all work the same. So indexing in Python is same whether you have a list, whether you have string, or whether you have numpy arrays. It is all the same, and it always starts from 0. That is the main thing. And whenever you have a slicing, so like this slicing is there 1 to 6. So whenever you have a slicing A to B, so it this is the start, which is inclusive, and this is the end, which is exclusive. That means it stops at end minus 1. Okay, and start is inclusive. So A is inclusive. That means it starts from A itself. This is how indexing is done in Python for lists, for strings, and as well as for numpy arrays. So now that we know this indexing for strings, the correct option in this case is going to be Braca. Why? Because let us write down the indices. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So this is going to start from 1. So it starts from 1 and goes up until 5, meaning it's supposed its end point is 6, so it stops at 5, and that is nothing but Braca. So again, let us see this in Python to convince ourselves that this is indeed the correct option.
So this is about indexing. S equals to abracadabra. See, it prints braca.
Moving on. What will be the output of the following program? Again, it is a recursive code. The function is being called by itself. So please take about a minute to answer this question. Okay, so the answer to this question is option A. Sum of first 10 natural numbers. And as I had mentioned earlier, so sum of first n natural numbers is given by the following formula: n into n plus 1 by 2. So for n equal to 10, this is going to be 10 into 10 plus 1 by 2, and this is nothing but 55. Okay, so this is the answer. Let us see it in Python.
Now another recursive code. So this program does sum of first 10 numbers. If I do 5, it should give me 15. Yes, very good. So it does sum of first n natural numbers.
Okay, so now the next question. Which of the following can be used to see the dimension of a NumPy array named ARR? So this is a syntax based question. Take a few seconds to answer. Okay, so the correct answer is ARR.shape, or you can use another syntax. Another way is NumPy dot shape of ARR. So these are two ways to see the dimension of a NumPy array. Either you can do name dot shape, or you can do NumPy dot shape of the name of the array. So two ways to accomplish the same result. Okay, so next question. If Python is encoded by TCXLSR, then diamond will be encoded as. We need to see this. So this is based on the substitution cipher example that we have seen in this week in the video lectures of encoding messages by substituting letters by some other letters, or by shifting the letter by a few steps forward or backward. So these are some simple ways of encoding messages and then decoding them back again. So try to figure out what encoding mechanism is used over here, and then using that encoding mechanism, uh, find out the encoded version of the word diamond. Okay, so let us discuss the answer. The correct answer to this, is option D. And how? Let me show it to you. So, what we have been given is the word Python, and this goes to the word TCXLSR, and the difference, let's say, between P and T is, so after P we have Q, R, S, and then T, so it is plus 4. Okay, so let us see whether this is true for all the other letters as well. So Y plus 4 would be Z, A, B, and then C. So correct. T plus 4 is U, V, W, and then X. Correct. Then H will go to I, J, K, and then L. So O plus 4 would be P, Q, R, and then S. N plus 4 is O, P, Q, and then R. So what we are doing is we are adding 4 units to each of the letters. So now when we have diamond, when we do plus 4 to each of the letters, D will go to H, A will go to, sorry, not A, for I is there in between, I forgot this I. So I just forgot about the presence of this I over here. So this I will go to J, K, L, and then M. A will go to B, C, D, and then E. M will go to N, O, P, Q. And from this we get the answer. We don't need to, because only different between C and D, the first difference is in this fourth letter. But just to confirm, we'll do for other letters as well. O goes to S, N goes to R, and D back again. We see from the first, D goes to H. So D goes to H. So this is the answer. Okay, so moving on. Select the correct statement. So we are given two statements, and then we are given some conclusions based on these two statements, and we need to select the correct conclusions. So statement 1 is print 9a.isAlnum will return true. That's statement 1. And statement 2 is 9a contains both alphabetic and numeric parts. And then these statements or conclusions are: option 1 is correct, option 2 is correct, and option 2 is the correct explanation for option 1. Then B is option 1 is correct, option 2 is incorrect. C is option 1 is correct, option 2 is correct, option 2 is not the correct explanation for option 1. And D is option 1 is incorrect, option 2 is incorrect. So the correct one is definitely option A, because option 1 is correct, option 2 is also correct. Why? Because is alnum method checks whether it has alphabets and numbers, either alphabets or numbers or both. If you enter special characters, then it will return false. Like if you enter full stop or hashtag or asterisks or exclamation marks or question marks, like those special characters, then it will return false. If you have only alphabets and numbers, then it returns true. And 9a is definitely both alphabetic and numeric. Why? Because 9 is numeric, A is alphabetic. So both are correct. And option 2 is the correct explanation for option 1. Why? Because 9a contains alphanumeric parts. That's why is alnum will return true. Okay, so let us move ahead. What will be the output of the following program? Another output based program. Here we have dictionaries. So we have seen the use of dictionaries as well. Dictionary is another data type in Python. Just like we have lists, we also have dictionaries. So please take about a minute to answer this question. Okay, so the correct answer to this question happens to be error. This particular segment of code uh, gives error, and if we want to achieve option A, let's say we want to find out a method of finding a dictionary with the count of each character in S, then for that we would have to write the following piece of code. We have def, we'll define a function, count letters or characters or whatever you can call. Then we initialize a dictionary. Then there is a for loop. Then we'll keep incrementing uh, the occurrences of each character by this +1 +1 and enter it in the dictionary. So this is defining the function, and if you want to call the function, for that we'll take an input string, and then we'll call the function, and then you can print it. So this particular piece of code will give you a dictionary with the count of each character in the string S. Moving forward, so this is the last question for these MCQ type questions. Okay, before that, let me just show this thing to you in Python.
So this is a question on dictionaries. Some random string is given. I'm not able to understand what this is, so I just write some random string. Okay. In the question, that string is there, it sounds meaningless to me. It's probably in some other language. See, this gives error, key error. Now, if we write it the correct way, as I had mentioned, for that, let me define this function. So we first need to initialize the key and the value, and then only we can increment it. So that's why the previous code was giving key error. Now this one will not give error. See, it is giving the dictionary where it is counting the number of occurrences of each character. So R occurs twice, once in random, once in string. Then space, here you see a space character that occurs once. Like this, it has counted all the other characters. N occurs twice, once in random, once in string, and then everything else occurs once.
So this is the last question for the MCQ part. Then we have programming assignment part. Let L be a list containing different names of movies. Which statement is correct to select a random movie name from that list L? So we had seen the random library and how to use that random library to generate random numbers or select random elements from a list. So this question is based on that random library. And the correct answer is option A, random.choices L. So it randomly selects element from the list L and gives it as the output. So this is the end of the MCQ type questions. Now we will move to the programming segment of this week. So the first question in the programming segment is as follows. Aman likes to study about planets. Every night he goes outside to observe some planets with his telescope. Then he guesses the distance of each planet and pens it down. In this process, he also pens down his favorite planet position. Given the distance of each planet to be unique, you need to return position of Aman's favorite planet after sorting all the distances. So for example, input will be n, which is the number of planets, the list L, which is the list of distances of planet, and K, which is the position of Aman's favorite planet in unsorted list. And the output is supposed to be a position of Aman's favorite planet in the sorted list. So one thing we should know before proceeding is about indexing. So what we need to note is that index is different from position. Okay, so let us say we have a list L which is the following. Let's say L is the following. Okay, so here we will have index is going to be 0 for the first element, 1, 2, 3 and 4, whereas position is according to humans, and humans start counting from 1. So position is 1, 2, 3, 4 and 5. So you need to note this difference between what is an index and what is a position. So now let us write the code. So first we need to take an input n. which needs to be an integer, so we'll typecast it into input int. This is the number of planets. Then we'll input a list. So this piece of code is used for taking input as a list of n numbers. Then we have to take k again as an integer input, which is the position of the favorite planet. So index is going to be k minus 1. So planet at that particular index is going to be this. Then we will sort the list. And then we find the position of that favorite planet. And we will do I plus 1 because I is the index. And once we find this, we do not want the loop to continue, so we will break out of the loop. So this is the piece of code. Let us see this in Python.
So now we are at the programming assignment questions. So this parenthesis is important. I think I forgot to write it in the notes. Okay, so this is the function. So no function over here, it's just printing, taking lists and printing. So let's get started. First is n, let's say 4, and let's enter distances for 4 of these. So 20, 34, then 56. Oh, sorry, I need to put it. Let's do once again. 4, then let's say 34, 12, 67, and 100. Okay, and then index. So index, let's say, is 2 at 67. So index is 2. So position in sorted list will be is 1. I do not understand. Oh, okay, let me print L. Oh, sorry. When we enter K, then that is the position. So position means it is not the index. So when I entered 2, that means it was for 12. Okay. So 12 is like second position, and in the sorted list, it is in the first position. So it is working fine.
Okay, so moving on to the next question. Romeo and Juliet love each other. Romeo wants to send a message to Juliet and also does not want anyone to read it without his permission. So he shifted every small letter in the sentence by -2 position and every capital letter by -3 position. So by example, we have seen that if it is a small c, then it will go to small a, but if it is a capital D, then it will go to capital A. The letter is too long and Romeo does not have enough time to encrypt his whole letter. Write a program to help Romeo which prints the encrypted message. Okay, so let us start this. This is a different way of encrypting, and let us see. So first of all, we need to import the string library, and then we'll take input as of the message as a string. All lowercase letters are in this string.ascii underscore lowercase, and all uppercase or capital letters are in string.ascii uppercase underscore uppercase. So let us initialize the answer, which is the encrypted message. Then we have a loop. So if the letter is a lowercase letter, then we'll decrement it by 2. And this is for cycling. That means if we reach the end, that means if we reach, let's say if we are at A, then -2 would be going to Y. So this modulo operation takes care of that cycling. And then we'll append it to the answer. Else, if this is a capital letter, For capital letters, we'll decrement by 3. And again, this modulo operation takes care of cycling. That means if we are at A, then minus 3 would take us to X. Then we will append it to answer. And if it is not an alphabet, if it is some number or some special character, then we will leave it unchanged. And then finally we want to print the message. So this is the code, and let us now see it in Python.
For this assignment, we need to import string function. Let me copy this to make my life easier. Okay, let us run this. So I need to enter a string. Let me enter random string. See, it does the encoding properly. So small letter, for small letter, it is doing -2. So R minus 2P. Okay, let me do small and capital both. See, for capital it is -3. So R minus 3 is O, because O, P, Q and then R. And then for small letters it is doing -2. So A minus 2 is Y, because Y and then Z and A. So what is happening is, after Y, if you go 2 steps, you go Z, and then because of cycling, you go to A. So A minus 2 will be Y.
Okay, so now next question. Write a function whole uh, n which takes n as the input, a number n, and returns the sum of the first n whole numbers. Okay, so this should be small n. Write the program using recursion. So we are supposed to make use of recursion to return the sum of first n whole numbers. So we have actually seen this earlier in today's lecture. One question was there in which we had to predict the output, and the output was basically the sum of first n numbers. So let us see it again. Let's say we want to define a function whole. So we need to make use of recursion. So this is the recursion part. So our function is called whole, and then we are calling that function again. So that is the function, and then we'll take input and then we'll print the output. So let us see it in Python. Let's get rid of this and let us write the new program. So we will define the function whole, and this is the base case. Every recursive function needs to have a base case. And then we will call the function recursively. That means the function from the function itself. And then we will take input and then we will print the corresponding output. So let's run this. We need to give some number as input. So 5 and sum of first 5 whole numbers is 50. That's right. So we can try for one more number. Let us see. So let's run one more time. 10, sum of first 10 whole numbers is 55. That is also right. So this program is working absolutely fine. Finally, the last question for today's lecture. Take a string s as an input and print palindrome if the string s is a palindrome, or not palindrome if string is not a palindrome. So a palindrome is a word which spells same from forward and backward. So example is kayak. So if you spell it forward, then it is K-A-Y-A-K, and if you go backward, then also it is kayak only. So and we need to ignore the case sensitiveness over here. So forward and backward both, they read the same. That is what is called a palindrome. So let us take s as an input string and let us convert it into all lowercase letters because we don't want to care about it being case sensitive. And let us call a reverse string, which will be the string in reverse order. And if the given string is same as the string in the reverse order, then we will print palindrome, because then that means it is a palindrome. Else we will print not palindrome. That means it is not a palindrome. Okay, so let us see this in Python. So let's write the code for the last programming assignment. This is for checking a palindrome. So we will take an input string, then convert it into all lowercase letters, and then we will take a reverse version of the string. We will reverse the given input string and store it in a new variable. And then we want to check whether the given input string is the same as its reversed version or not. If it is the same as its reversed version, then we will print palindrome, because then that means the given input is same as its reversed version, so it is a palindrome. And if not, then it is not a palindrome, so we will print not palindrome. So this is the code. Let us run it and let us enter a string. Let's say kayak, the given example input, and of course kayak is a palindrome. Let's try once more. This time we will enter word, and word is not a palindrome, so this code is working absolutely fine. This brings us to the end of this week, and the major takeaway from this week, major concept, has been that of recursion. So you should try and focus on understanding recursion properly. So it is a little bit difficult at first sometimes, but once you get a hang of it, you will really like the concept of recursion. And once we understand it, it really becomes easy and it makes things faster. So this is one main takeaway from this particular week. So see you in the next lecture.